Hello, everyone. Welcome to Conf42 JavaScript track. I'm really excited to be speaking about this topic. It's called Mission Performance Impossible, Real-Time Chat Web App Performance. My name is Zubair. I'm a software engineer at Mattermost. So a little bit about Mattermost. It's an open source collaboration platform for communities, enterprises, teams. We have been very focused on Mattermost being an entire suite of platform tools for entire software development cycle. Now, before we begin with the topic, let's first understand the architecture of the web app. Mattermost web app uses React as its front-end library to make the web application. So as everybody's already aware, React is more efficient when we have a lot of updates, and indeed the components which have changed only have the difference in visualization of what components have actually are supposed to re-render instead of re-rendering the complete tree. As a state manager, which we are using is Redux with Thunks library separately. It serves, as I've said, it serves as a state manager of the application. And I think everybody's aware of Redux. It's a very predictable state container library for React. It also handles asynchronous logic for interaction with networks and all the other core features. The next is technology which actually makes the web application of Mattermost real-time is WebSocket API. This WebSocket API enables us to have real-time communication between the client and the server. And this obviously is very crucial for the chat application to be able to serve in real time. And yes, all of that, the application is single-bit application, which enhances the user experiences by reducing frequent page loads and all that. It's entirely modular design. And it's open source. You feel free to just check out the repository and the code behind that. Everything is modularized into components, actions, selectors, and the UI component library, all that. And as I've already mentioned, real-time updates with WebSocket. The app maintains a persistent connection to the server, allowing for the instant data push and updates without requiring much user interaction. Now, with this, let's try to understand what are the challenges of real-time application. Now, when I say challenges real-time data, I'm purely talking about in respective of the client performance. The real-time application on the server side is again a completely different story, which needs its own talk. But this talk is concerned about the client performance, my client and the web application running on the browser. Now, when things are real-time, there's a high volume of incoming network requests with WebSocket events. And most of the times, this incoming network events also must be followed up by the client by more network requests. For example, if we have a post coming in, we usually don't send the user's complete information who's sending the post. Now it's up to the client. If it has that user ID particularly stored in the Redux, it's well and good. If it's not, then again, it has to go back to the server to fetch the user details for you. Now, in high elevated environment, this could lead to a lot of network traffic when your client is constantly responding to the new incoming WebSocket events with more network events. We get to this is one of the problems which we have faced. We'll get to that problem in a bit. Now, there is always a constant battle between what to fetch and what not to fetch, or what to fetch later on. So with real-time data, you have to always have this balance of overfetching or underfetching. Keeping all of this there, your UI has to be responsive, has to be interactive by the user, because user is concerned about using the application. Your app has to support that. Now, there were a lot of performance optimizations which had to get in to elevate the load bearing capacity of the client. We'll get to some of the PRs, not all of them, in a while. But before that, let's try to understand how can we simulate this, right? Because if you are testing on a local environment, you won't have this many users signing up, this many users sending the post, people joining channel, people reacting the post, people commenting on the post, and all that. Mattermost has an inbuilt tool called Mattermost Load Testing NG, which it uses to stress test the server environment. A little bit about the architecture of this particular tool. It's an in-house tool developed by Mattermost. We have, I think you're already seeing the architecture over here. Just a very big, very high-level view. There are two main components that we should look out for. That is, the first one is a user controller. Now, this component is actually in charge of driving or controlling the user. By user, a simulated user, right? Its implementation is what defines what exactly the behavior of the user is. Its action could include what the user might do when it opens the Mattermost. Like it might go to type a new post, switch channels, switch teams, open a new thread, or react to a post. So all of this is implemented in the user controller module, which you can see over there. And then another thing which we should also be aware of is the coordinator. Now, this coordinator is in charge of managing the cluster of load test agents. By load test agents, and then it's trying to figure out what is the maximum number of concurrent users the particular server or active server can have. So again, this is, if you can see, there's a loop going on from coordinator directly to Prometheus. It's a loop back, simple feedback loop. So when the load test starts, the coordinator will begin increasing number of users. And at the same time, we'll also start monitoring or acquiring the Prometheus server by collecting its server metrics and saying, are we reaching our target limit or not? Then based on that, it will start increasing the active number of users slowly. And once the equilibrium point is reached, it will stop by equilibrium when no more active users can be added. And that would indicate that these are the maximum number of supported users this particular Mattermost server can have. With this are all is happening on the server side. What we would like to do is have an extension of this for the client. So into one of these app instances, we are going to connect our client and see how the client performs when all of these user controllers are working in tandem, doing all sort of things, all expected user behavior. Because that is how the application would be used eventually, right? So for this, what we did is we have automated test running on the client, which will open the web application when the load test is being run on the background. And again, the front end load testing tool will start interacting with the application, the real-time application. Now, as you must be confusing, how you said the user controller is doing the interaction, but yes, user controller is doing on the server side. But we need the client-side metrics, right? So that's the reason we need to connect a client and then run an automation loading tool to get the actual browser metrics and what the actual user is seeing. And for that, we need to connect it to a browser. So as you can see, once we start doing that, it runs whole suits. It runs for some time. It runs whole suits of tests. And with this, we are piping all the data to the Prometheus server, which is already there in our load testing instance. And with that Prometheus, we are scraping, Grafana is scraping Prometheus to get us the useful analysis which we would like to see. Now, I told about this, like analysis, like what the metrics are. Let's try to understand what these metrics are, right? Now, before going to the metrics, how can you compare two versions of your Mattermost application, right? So what we do is, for the version number A, we run the load test, wait for the equilibrium to set in, get the app node, run the client automation test, run it for some time, see the Grafana dashboard, take the metrics from the browser, and then we run it again with the equivalent or exactly the same environment variables which I have done for the past test, now with a with a different client version. And then that is how, after again running the same step, then we compare, have we improved or not? And that is how we analyze, okay, are we improving the performance of web app, or are actually degrading that? Now, with this, let's, as I've mentioned that the metrics which we are talking about, let's try to understand what are the few of the metrics that we track in the client side. Now, this is important. Now, even before going to the actual metrics, the reason, there are a few things that we need to understand. These client-side metrics are very much dependent on the hardware. And because the hardware is constantly changing with any number of clients, right? Because each one of them have a different browser or have a different hardware. All the users, even them, although all of them are on the same Mattermost instance. So that's the reason I've said that comparison is the key over here, not the absolute values, this metrics. So with that, the first thing which we do is we use the Chrome DevTools to see if there are any memory leaks or not. So we do the memory profiling. And with this, what we are basically trying to see is, are there any memory leakages or are there any inefficient memory uses? With this, what we can see is, will this excessive memory leads to crash or slow performance, right? Once we do find out, okay, there are a few things that we need to do, then we have to follow up with efficient data structures. If you would like to see the structures or efficient calling of functions, so that our memory allocation optimization, we have optimized memory allocation. We also monitor CPU usages. So this identifies us if there are any processes bottlenecks, because high CPU usage can slow down the complete client, affecting response times or application performance. Not only Mattermost application performance, it also degrades other applications which are open onto the user's computer. So we profile the CPU and see what caused, if there are any spikes, then we go back to it and see what caused this additional computational overheads. Another metric which we also see is, what is the frames per second when the user is interacting with the application. Now that is on the top left, as you can see. Again, available in the Chrome DevTools. It's a measure of how smooth the animations or interactions are taking place in your application. Obviously, low FPS leads to choppy visuals, delayed responses, very bad user experience. So we identify which process is causing low frame rate per second and concentrate on that to see how can we improve that, how can the re-renders be improved, and all that. Another useful tool, which we also take a snapshot of, is the network HTTP archives, or HARs, HAR. What this will allow us to see is, are there any long pending network requests which are being carried out by the client, which we might not be aware of, but client is making that, and see how other web assets are loading. Are there any network bottlenecks? Because what happens is, although the browser does not have any limitations on number of requests being sent, but this network request, when the response from these network requests comes in, the client has to get this data, understand where in the place of redirect it has to place this data, do a lot of re-rendering and all that. So although network request doesn't cost us the memory usage, but the following processes after we get the response are the heavy ones. Optimized network loading is very much appreciated. And the next thing is, we have the Web Vitals library from Google as well, which help us to understand various stable industry recognized web metrics. For example, FCPs, LCPs. Like FCP is the first contentful paints, cumulative layout shifts, and all that. Is an amazing library made by the Google, which you can incorporate to, and which would track all these numbers for you. So measurement of these vitals and also comparison is one of the vital performance tool which we have in our arsenal. Running Lighthouse is another process which we have. It gives us a holistic view set by Google Lighthouse tool. Is again not only the metrics which we talked about earlier, but also other metrics which are very useful. For example, the accessibilities, and it also gives a very helpful recommendation on how to solve this performance bottlenecks. So we have the FCP, which is the first contentful paint. It's the measurement of time when the user first have navigated the page and any of the part is rendered on the screen. That's the first contentful paint. And the largest LCP is the largest contentful paint, is basically the time between one of the largest element on the page which appears. And then we also have interaction to next paint, again, which is a very core web vital for us. It basically measures how much of the we have with the user interaction when the user first lands on the page. And then we also have other things like total blocking time, speed index, all of that here. Then we also have a specific set of custom Mattermost metrics. For example, channel switch time. Like how much time does it take for, on an average, for the user to change from one channel to another or from one team to another. All these are custom metrics which we have defined in Mattermost. And yes, we keep on defining or developing these custom metrics as a part of performance analysis. Now with that, I think now we have understood like what all metrics which we look out for and how do we do the comparison and what is the process that we follow to load test on the client. Let's quickly look at a few example PRs just to get an understanding of how the actual process of work is being done. So this is one of the things which we have seen when we ran the load test on the client is there was a very high memory usage of one of the reducer. And we have seen that it was like 34% of the memory usage in that particular interaction. We had to reduce that, but why is that even happening? It turned out that we were not actually getting, we were getting objects which were not being recycled by the Chrome, and they were having some dangling objects which were not being garbage collected. And if they were dangling objects, we had to, usually what happens is when you run a garbage collector, it stops the whole application and then runs garbage collector. So GC run by the browser is intensive operation. I need to avoid that as much as possible, not completely avoid it, but yeah, as much as possible. So this was one of the things which we had, and we were using few of the arrays patterns which solved the issue, and we were able to get down a significant usage by these particular arrays. There was also another one which was causing some of the issues was that we were using a library for the profile popover and all that. So which were causing a significant memory leak, which we were able to find out. So one of the method was to either have it custom built by ourselves or replace the complete library, an existing one. So we had the base library changed to a more new and supported library without this memory leaks. And yes, we had a lot of improvement when we actually changed the popover library and performance of that. And what another investigation which we also did was we had a lot of network calls being sent to get statuses and user IDs. When the new message was posted. Now, agreed, there is a little bit of what you can say. We don't have WebSocket event when someone changes the statuses because there are some performance bottlenecks we have from the server, and that is one of the limitations which we have. That's the reason we don't have we don't send out a WebSocket event when the user status is changed. So what we had to resort for is manual fetching after some amount of time, fetching again the user statuses. Now that was repeatedly hammering the Redux store, updating that. The whole application was very much freezing. We had to do something about that. What we ended up doing was we created a simple data manager for statuses and also varieties, which would keep a queue of the statuses and then execute after a certain amount of time. That solved the issue. And yeah, that after how much interval that this particular queue has to get cleared, that is again configurable by the application. And there was also another, I've studied about the network request. So we also saw like an unwanted network request right before. So yeah, again, there was one of the thing which we saw is it was unnecessarily fetching the complete thread when we are not seeing that particular channel. So as you can see, if you have noticed, all of these PRs, and not only this PRs, but any of the performance PRs have a very good backing of reasoning of why this particular performance improvement is important by having a sound comparison between before and after effects of the PR so that we can see visually, okay, this has improved by this particular percentage or by this particular metric. And not only it helps but also it helps in the future as well when we go back to this PR and see, okay, why did we do that? And at that particular point of time, we saw, okay, this was the improvement which we have seen. Now, let's get back to now. We have seen a few of the examples, work which was done on Mattermost, the client side. Now, obviously, there are a few caveats with this. No matter how much performance improvement you do, network latency will eat away all your hard work because that's just a hard reality. So even if you have improved like 30 milliseconds of improvement, if your server, if you have a large latency, all of that performance goes to waste. And then client, as I've also mentioned earlier, client-side performance has a lot of dependent factors. For example, what kind of hardware they have, what kind of browser they have, what kind of other application they have running alongside the Mattermost application. So yeah, so that's the reason I've said comparison is the key in load testing client. And it so happens that the performance, for example, it so happens that when the user loads the application and the first time it is slow, the user perception is that application is bad. So user perception regarding performance is very much different. That's the reason that you have to do your own load testing on the client or not rely on server's feedback. Or you know what, channel switching is slow, team is slow. We cannot rely on that information solely. And then we have to just replicate exactly what exactly is happening with our load testing tool to understand where and when the problem is arising. And not all your performances improvements will be linear. It might be, some might give you a lot of gain, some might give you very less gain. So that's always there. Now with this, I'd like to conclude my talk. If you have any questions, please reach out to me. And I'm available at my website over there. Thank you so much for listening. And once again, it was lovely talking, presenting all of you. Thank you.